Hello, and welcome to this AWS webinar. My name's Ian. I'm a technical evangelist with Amazon Web Services here in Europe, and I'll be your host for today's webinar. As you can see on the slide, and you'll know from your registration, the topic for today's webinar is the Elastic Compute Cloud, EC2. And this webinar is part of our Masterclass series. So we run two series of webinars here in the European region. The Masterclass is intended as a technical deep dive, which will take you beyond the basics on one specific AWS service and educate you how to get the best from that service and the technology that it involves, show you how things work and help you get things done. And it's going to last about 45 minutes a session today. We have another series of webinars called the Journey Through the Cloud, which you might be aware of, which are intended for intermediate level users and are more solution orientated. So if you're interested in finding out more about how you can apply the different services that AWS can provide into your organization, then join us for the Journey Through the Cloud series, and you might also find those webinars interesting. Just three bits of logistics before we start getting into today's content. The first thing is on questions, so you can submit questions throughout the webinar today. You'll probably have guessed that there's a lot of people on the line for this webinar because EC2 is one of our most popular services. So it's possible that we won't have time to get to all of the questions during today's webinar, but if that is the case, we always follow up on the questions after the event. So submit them anyway, regardless of whether or not we can answer them in the session. Somebody from AWS, either myself or another member of the team here, will get back to you and answer your question within a couple of days. We're always asked, of course, whether the materials are available from this webinar, and they're made available immediately after the session. Both the slides are available, and in addition to the slides, there's also an instant recording of the webinar available. So if you miss something or you want to dive into one of the sections of today's webinar again, then please feel free to download or re-watch the recording. And of course, you can share the recording with colleagues or friends that might have missed the webinar and you think it might be useful for them. And secondly, you can of course share the materials with colleagues as well and download the materials. So all the materials will be available for you immediately after the session. So let's get on into the topic for today's webinar, which is Amazon EC2. So what is Amazon EC2? Well, it's on-demand compute that you can use as you see fit in order to run your application workloads. It's a disposable resource, very easy to access, very easy to set up, and also very easy to dispose of. And this theme of disposability is one of the key themes that we're going to be returning to throughout the webinar today. So just keep that at the front of your mind. You'll see it's a sort of recurrent thread that we'll touch upon quite a few times during today's session. So Amazon Web Services provides the infrastructure, the EC2 compute infrastructure, and you decide what you want to run on that. So it's a very flexible service. That's the first thing to say. You can access it and run a variety of different operating systems, and you can manage it and control it in a variety of different ways. And that's going to be a key area of focus for the webinar today, to try and explain to you what some of the options are for managing and controlling your EC2 resources in a more efficient and effective manner. It's also secure, and Amazon Web Services has achieved a number of external security standards and being audited against those security standards, and EC2 is included within that. It's inexpensive, with small instance types being extremely cost effective, and the on-demand nature of the service, of course, means that you're only ever going to pay for what you need in order to run your applications while you're running them, which can also improve the economics. It's a reliable service, the capacity is elastic, and you have complete control over what you do with it. So before we get into some of the detailed parts of the content we're going to cover today, it's worthwhile just covering some basics and explaining some terminology, giving you a kind of basic understanding of how the service works so that we can then build on that foundation in the rest of today's session. So obviously the EC2 resources are presented using virtualization, and I'm sure you all know this already. So we're using a virtualization hypervisor, which in our case happens to be the Zen hypervisor, and we're using that to partition and securely segregate the resources that are made available to different customers within the shared environment, and to manage the physical resources that underlie that shared environment, whether that's compute resources, memory resources, or network resources. They're all managed and controlled by that virtualization layer, and your workload will be securely segregated from other customers that might be running on the same physical platform as you. And once again, that segregation has been audited by third parties, and you can find a lot of information about how AWS services are secured and how EC2 is secured specifically if you visit aws.amazon.com/security. So let's continue with this discussion of terminology. The first important piece of terminology that we're going to be using a lot throughout today's session is the ARMI, the Amazon Machine Image. This is the freeze-dried template from which your instances are started. So when starting an instance, you're taking that ARMI and you're turning that into a running or stopped virtual machine, an instance, and you then deploy that instance into a VPC, which is the construct that we use to enable you to define and control your own network topology, your own security rules, and the layout of your virtual private cloud, your virtual private infrastructure. So your instance will be deployed into that VPC. These VPCs sit within regions, which have within them availability zones, and we have multiple availability zones per region. Each availability zone represents an independent failure domain comprising one or more facilities. So you know that if you distribute your application across multiple availability zones and distribute your instances across multiple availability zones, you can get very, very high levels of availability for your application. And you can build an application in a way which is disaster tolerant and fault tolerant, and actually in a way which traditionally has been really reserved for very large organizations, those that can afford to have, multiple data centers and high bandwidth optical networks between them. So AWS really unlocks those resources and makes them available, those high availability resources, and makes them available even to very small organizations, very modestly sized customers. So you should take advantage of the availability zones and build your application in the right way. Other services that are important, and we're going to be covering to some extent during the session today, EBS, the Elastic Block Store. So within each availability zone, we provide a set of services that enable you to present block devices to your EC2 instances. Those block devices you can obviously place file systems on. You can aggregate together using software RAID techniques to provide your compute resources with the storage that they need to operate your applications and, of course, store your data. So we'll cover EBS in some detail in a later section of this webinar today. Those EBS resources, by the way, are specific to an availability zone. So instances in one availability zone will have access to EBS volumes there, and instances in another availability zone will have access to EBS volumes in that availability zone. And underpinning that, we have our S3 service, our simple storage service, which is highly durable and extremely scalable object storage. And that's where things like EBS snapshots are stored, and actually it's where ARMIs are stored before your instances are created as well. So an adjacent service which is used to provide highly durable storage for snapshots and for machine images. So that's the basics of terminology covered. How should you think of your instances? So we're just going to talk about three different things that are slightly, I would say, are specific to getting the most out of EC2. And if you think about your instances in this way, you'll find that you have the right mindset in terms of maximizing value that you get out of EC2. So the first thing to think about is that your instances are a unit of control. And what I mean by that is that you can bundle your stack onto an instance, and you can make that bundle your unit of control, determining later on what kind of instance you're going to run that stack on, and also what location, region you're going to run that stack on. So if you bundle up your software resources and treat them independently of your instances, that can be a good point to start from in terms of getting the most out of EC2. So just bear that in mind. We'll come back to that later on in the webinar and discuss it in a bit more detail. The second thing is this idea of using the instance as a unit of scale. So it's very easy with EC2 to scale out and to build large fleets of instances in a highly automated manner. And this allows you to do a couple of things. The first thing is it allows you to play with economics. So it's potentially more cost effective for you to run your application across a large number of smaller nodes, a large number of smaller instances. And you should think carefully about what the right instance type is for your application and how you're going to leverage that idea of scaling your application out. And of course, by doing that scale out, you get another benefit, which is improved resilience. So if you have a large array of instances that are running your workload, none of those instances are going to be a single point of failure. So if you do lose an instance, as you can see here, for any reason, hardware failure or software crash on one of your instances, your approach can be to replace that, very simply, replace that instance, have another instance take its place within your fleet, and at that point you'll have the same amount of capacity for your application, and your resilience characteristics will be restored. And EC2 makes it really, really easy to do that, to treat your compute as a disposable resource, which you can quickly and easily replace if you have any issues with it. And we're going to cover some of the techniques that you can achieve that in an automated and simple manner as we move through the webinar today. Okay, so the next thing we're going to talk about is instance types and choosing the right unit for your workload. You can see here a slide which maps the different instance types that AWS offers, and the bottom axis here shows compute units, EC2 compute units, so how much relative CPU power the different instances have. And the vertical axis shows memory, so how much RAM is available to the different instance types. And you need to just bear in mind that those are log scales, so every time you cross one of those grid lines, you are doubling the amount of memory or CPU performance from the previous grid line. So you can see there's a pretty broad spectrum of different instance types that are available, all the way down from the little T1 micro that you can see highlighted with the orange box on this next slide, through a series of general purpose instances which have balanced amounts of CPU and memory. And we just introduced a new family of those general purpose instances called the M3 family. We're adding to that as time goes on. And those basically offer enhanced CPU performance at the same price point as, or slightly lower price point actually, than the prior generation. So it's very, very easy to move your workloads between different instance types once you've created them. We'll talk a little bit more in the session again about how you do that. So those are general purpose instances which have balanced amounts of CPU and memory. We also have special purpose instances. So the red boxes here are showing compute optimized instances that have a disproportionately larger amount of compute relative to the amount of memory that they have. And the very largest instances here are having up to 108 times the CPU performance of that T1 micro or the M1 small that you can see at the far left-hand side of the graph there. So very, very powerful systems. The green instance types here are memory optimized, so disproportionately more memory than they have CPU. And again, there's a very large instance type available here with 224 gigs of RAM and 108 CPU units. So if you have very large HPC workloads or very large in-memory databases, they can be catered for with an instance type. And it's very important to pick the right instance type for the workload that you happen to be running. And we've not mentioned now on the chart, but they were on the chart, another 3 sets of instance families: a storage optimized family, an I/O optimized family, and a couple of instance types that are backed by GPUs, which you can use for accelerating operations that require very, very high floating point performance, accessing the GPUs via an SDK that's available, and using them to accelerate floating point operations. You can find out much, much more about the different instance types that are available if you follow the link that's at the bottom of the slide here. And of course, if you download the materials, you can click that link in the materials. You'll be taken off to a page on the AWS website, and there's a whole lot more detail there about the different instance types that are available. So you can match your workload to an instance. And as I just said, it's super easy to change an instance once it's running. So if you have an instance that's running, go into the EC2 console, look at your instances, right-click on an instance that you want to resize, and you'll see an option there for Modify Instance. If you select that option, you can then change the instance type. The instance can be rebooted, and when the instance is rebooted, it will come up on new hardware. Of course, it's new virtual hardware, but you can bring the instance up very quickly on new hardware that has improved performance characteristics, or just has a different blend of CPU to memory to I/O. So if you have a performance issue, it's possible to address that, or a scaling issue, it's possible to address that as simply as just right-clicking on an instance and modifying it. So very, very simple and easy to scale up. And for that reason, I'd always encourage people to start with a small instance. You know, don't overcook or overestimate the amount of capacity that you're going to need. You probably just end up paying more than you need to. It's very simple and trivial to upgrade your instance at a later stage. So start small. It's very easy to upsize, and that will help you be more cost efficient and pay as little as possible for the services that we provide to you. Okay, next we're going to move on and talk a little bit about armies. So the Amazon machine images, these are the gold masters, the templates that are used to build your instances from. There's 3 different types that you need to be aware of. The first is Amazon maintained. So this is a set of Linux and Windows images that Amazon maintains. We keep them up to date by region, and they're available as launch options within the EC2 console. There's a pretty broad spectrum of different flavors available, which we'll talk about on the next slide. The second kind of army is a community-maintained army. So these are images that are published by other AWS users, either individual users or there's quite a large number of this second type, which are armies that have been created and they're managed and maintained by marketplace partners. So some of them have things like open source software bundled onto them. You can find things like the Bitnami WordPress or Drupal stack there bundled onto an army and available for quick installation and operation, all the way through to things like Oracle Linux available as a packaged army within the marketplace. So community maintained, either maintained by other users or managed and maintained by marketplace partners. And then lastly, you can create your own armies from EC2 images, and you can keep those private, or you can share those with other accounts and make those community armies. And we'll talk a little bit more about circumstances where you might use your own Amazon machine images later on in the webinar today. Now, the different armies have different cost points and different price points, and you can see here a selection of starting prices for different instance types, different armies. So Linux, the Amazon Linux and Ubuntu Linux, they can run on a small instance from as little as 6 cents per hour. Enterprise Linux, we have a licensing fee that we have to pay to the provider of that software, so the costs are slightly higher. We pass those through to you in the form of increased hourly charges, and the same deal with Windows. And there's a wide variety of different armies that are built around those two different Enterprise Linux and obviously around the Windows operating system. If you explore those in the console or explore them in the pricing sense by visiting the URL at the bottom of this slide, be able to see a complete list of the different options and also understand what all the pricing options are for those different machine images should you choose to use them. So once you've decided that you're going to run an instance, it's worthwhile just exploring 3 different ways in which you can acquire and pay for the instances that you're using. The first is on demand. So this is what you might consider the classic way of consuming EC2. You pay as you go for your compute power. It has a low cost and it's commitment free. So you're just paying by the hour for the resources that you use. It's good for applications that are unpredictable, that are short term, and it's also good for application development and testing where you might only need an instance for 1 to 2 to 4 months. You know, short term, pretty unpredictable workload profiles are a good fit for those on-demand instances. Second instance type, the reserved instance type, this is not a technical construct, this is a billing construct, and this is a way that you can reduce the cost of your EC2 resources by committing to it over a longer period of time. What happens here is you pay a pretty low upfront fee, and in return for that low upfront fee, you receive a significant hourly discount on your instance while ever it's running. And you're probably thinking that means that you need to be running these reserved instances 24 hours a day. Well, that's not the case because we have 3 different bands, utilization bands for RIs. If you do have a workload that's running continuously, then you can pre-book your instance for a 1 or 3 year term using the heavy utilization RI type. And that can lower your cost by up to 55% if you're buying over a 3 year term. So you need to make a commitment for a longer period of time, but in return for that, you will get a dramatically reduced cost profile. The medium utilization RI is intended for workloads that are going to see between 41 and 79% utilization. That'll lower your cost by up to 49%. And then the light RI, it's intended for workloads that you're running in the region of, let me just work the numbers out here, 3 to 10 hours a day. Book your workloads onto these light utilization RIs. And in that particular scenario, your cost will be reduced by up to 34%, and it'll make it much more cost effective for you to run your workloads on EC2. So the last kind of instance type is the spot instance. This allows you to bid on unused EC2 capacity. So what we mean there really is you can acquire vacant capacity on Amazon EC2, and you can use that to run short-term dynamic workloads. So it's used extensively for applications that have flexible start and end times. And it's also good for applications that it's only feasible to run at very low price points. So those spot instances, you can specify that you want to use a spot instance at the point at which you launch an instance. And at that point, you'll place a bid price for that instance. If the market price of that instance type is currently lower than the bid price, you'll be given access to it immediately. If it's not, you may have to wait a little while for the market price to fall to the point at which your bid becomes higher than the market price, and then those compute resources will be made available to you. So let's move on to a little bit more technical detail now. How do you launch an instance? We're going to look here at commands, key pairs, and security groups. One of the easiest ways to launch an instance, of course, is to do that through the console. You can see here the console that you're presented with, and there's a listing here of the Amazon AMIs that are available to you through the Quick Start interface, and you can see a variety of different operating system types are available to you there. Once you've clicked through that and select Next, you'll be asked for a little bit more information. You need to supply this information if you're going to start an instance. So the region that you want to start your instance in, the instance size, which Amazon machine image you wish to use, a key pair that you're going to use for accessing your instance, and the security group that instance is going to sit within. And the first thing to talk about here is key pairs. So these are a way for securing access to your instance, and they're used either to secure access via SSH. So in this case, a public key would be inserted into each EC2 instance that you launch, which corresponds to the key pair that you've just selected. You'll have the private key on your system, and you'll use that to create an SSH connection to a Linux instance. These are also used with Windows instances to encrypt the administrator password on the instance. So in this particular case, this is how we ensure that only you will have the administrator password for first logon, because that administrator password will have been encrypted with a key pair that only you have access to. So they're a critical way for securing access to your instances once they're running. There's two other important bits of credential information that need to be aware of. There's something else called a key pair, which is used, or rather an access key and a secret key. This is used for authenticating against AWS APIs, so that's something else from the key pair. And historically, we've also had X509 access for some APIs, but that's been deprecated later on this year. So if you create a new account, you will not be able to use X509 certs for SOAP access to the APIs. You have to use the access key and secret key for REST-based access to the APIs. Security groups. So this is about instance firewalling. Now the default with instance firewalling is that your instance is completely locked down and no one can access it. And that's common actually with pretty much every AWS service that we provide. So in order to permit access, you have to actively take some action and open that up. And security group has a few attributes. Basically what you do with them is you specify different types of traffic and different address ranges, IP addresses, or other security groups that you want to be allowed to access your instances through the software firewall. And that will allow you to restrict access to your instance and only allow the right kind of traffic that that instance should be managing to reach it. So it's really a mandatory way for you to lock down your instances and secure them in a way which will prevent unauthorized access. Now, launching an instance from the command line, you've got a few different options to do that. We're just going to show you three quick examples. So this is an example of how you would launch an instance from PowerShell using the new -EC2 instances command and passing in some attributes there that specify the image ID, the army you're going to use, the key pair that you're going to use. This time we're specifying a security group by its unique ID. And you can see here we're launching a T1 micro instance. You can do the same thing from the Linux command line tools. And here you can see AWS EC2 run instances. Once again, we're passing in an image ID. This particular example, we're specifying that we're going to launch two instances. We're specifying security groups, the key pair name we're going to use, and we're launching an M1 small instance in this example. So you can see the syntax is similar, and we need to pass this information in every time we launch an instance so that the EC2 API knows what we want to execute. And the same here, this is with Python Boto, which is the AWS-maintained Python library for accessing and controlling EC2 and other AWS services via the API. And here you can see that we're creating a connection object to connect to the EC2 service in the US East region. And then we're running instances using a method in that connection object, creating, again, a specific army, key name, M1 small instance, and adding this time the instance to the security group called web servers. So you may, and actually we recommend this just by way of a tip, you may use these tools directly on an EC2 instance itself. And this is a super way for setting up the command line tools very simply and doing that in a really quick and easy way. So using something called an IAM role, you can assign authority to access the AWS API to an EC2 instance. And you can see the creation process for that on the right-hand side of this slide. Going into the IAM console, the Identity and Access Management console, selecting Create an IAM role, and then creating an AWS service role for Amazon EC2, which is at the top of the box that you can see there on the right, and then pasting in the policy statement that you can see at the bottom there into that role when you've created it and giving it a name, AWS Tools in this case. You can then launch instances from the EC2 console or from the command line, and you can assign those instances that IAM role, and that will do something pretty clever, which is to embed and present the credentials that are required to access the AWS API and give them to that instance via the metadata service at the time that the instance starts. And those credentials will be automatically provided with keys, and key rotation will be managed on your behalf. So it's a very easy way for you to give API access credentials to the command line or to a set of SDKs without having to install anything on a system on your premises. And that's the recommended way that we suggest customers use the command line tools. Firstly, because it eases the setup, but secondly, because you can terminate or stop that instance when you're done, and there'll be no chance at that point of anybody using the command line tools in an unauthorized way or in a malicious way. So it's a good way to create what's in effect a bastion host for controlling AWS via the command line in a very simple and easy way. We're going to show you another way that you can use that metadata service later on in the webinar today. So now you've got those tools, you can try two different things. You can run instances with a reduced set of parameters. So in this particular example, we're issuing that run instances command to start two instances of that particular image type, but we're omitting the security groups, the key name, and the instance type. And what happens is those are set to default. So the security groups will set to default. The instance type will set to the M1 small type, as that's the default in this particular account. And the key name will be set to none. Now, that idea of setting the key name to none is something that we're going to focus on a little bit now, and that's an important way for improving automation within your account and also improving security. So if instances don't need key pairs, how do you configure them if you can't log onto them interactively using either RDP or SSH? And the answer to that is to use a technique called bootstrapping. And there's basically two different approaches that you can use for bootstrapping. The first is to do what we described earlier, which is to create a custom army and use that custom army to start an instance in a known state. So you would do that by starting an instance, configure your instance in the way that you want your army to be configured, shut your instance down and snapshot it, and create an army at that point. And then you can start new ones from that army, and they'll be in exactly the same state as that instance was when you snapshotted it. So that's one way to do it. The second option that you've got is to configure dynamically. So launching an instance and using a metadata service, which we described earlier, together with something called Cloud Init to perform actions on the instance when it launches. And of course, you can also combine those two things together. So building a base image which has custom setup and initialization scripts on it and maintain that as your golden base, and then combine that with dynamic configuration, passing bootstrapping custom information to perform tasks at the time at which that image boots for the first time. And that would be things like pulling code from a version control system like SVN or Git, and applying security policies, and finalizing the configuration of your instance. So you can combine those two tools together. And the reason that you might combine them together is that at opposite ends of this continuum here, you've basically got two different sets of characteristics. If you're into the army-based model, it's time-consuming at the point that you create the armies, and also you've got a static configuration then, which is going to be identical each time you deploy it. The other end of that continuum is you have complete dynamic configuration where you're going to be grabbing packages and potentially updating packages every time you start an instance, which can be a lengthy process. So for example, if you're running Linux, you probably don't want to run a yum update every time you start an instance, because it could take several minutes for that instance to become available. So you can bake that into an army and just do that on a periodic basis and have a smaller amount of on-demand activity taking place at the point at which you start your instances in order to reduce the startup time. So you need to consider where on that continuum you want to be in terms of your deployment model. Whichever way you do it and however you combine those things, obviously the goal is to bring up your instances in a useful state. So the balance of them is going to vary depending on what your application and the role type is for your instance. But let's just dig in a little bit into how that auto configuration works and how you can bootstrap your instances in a dynamic way. So as we said, we're using this user data which is held within the metadata service that exists within EC2. And your instances access that metadata service at the point of boot. So you can use that in a customized way, if you wish, to process and act upon that metadata in a way which you define with tools that you've developed and placed within your army. As standard, though, the Amazon Linux instances that AWS provides enable you to execute shell script commands which you might embed within user data at the point at which you first launch an instance. And you can see here an example of one of these scripts that would install a web server, PHP, and MySQL tools onto a system. It would set the web server to start automatically on reboot, and it would start the web server service at the point of initialization at which the instance was created. So that's a method for automating the configuration of instances at the point at which they're created. You can do exactly the same thing on Windows using something called the EC2 config service, which is provided within the Windows distributions that are in the armies that Amazon provides. And you can execute PowerShell or script at the point at which you start the instances to once again perform that configuration in a dynamic way. So by minimizing the amount of human involvement and interaction involved in provisioning instances, what are the kind of benefits that you can drive? And they're summarized on the slide that you can see here. So more secure, more automation, because you've got less human beings involved in the provision process. Better availability because you can replace instances with healthy instances in an automated way if they fail. You can scale and manage your estate in a more efficient and scalable way. And you've got complete flexibility to use a wide variety of different tools for bootstrapping. We've described there examples using Shell and PowerShell, but there are also other tools that you could use. Amazon CloudFormation is one example. You could use configuration management and deployment tools like Chef and Puppet at the time at which you boot your instances, or you could use another AWS service called OpsWorks to do that. So got lots of flexibility, but the same principles apply. Improved security, automation, availability, efficiency, and a better ability to scale if you automate those startup time actions and do them automatically when you create an instance and boot it for the first time. So some do's and don'ts from those first few sections where we talked about instance types, securing instances, tools, and bootstrapping. So do use IAM roles. Do give authority to your instances to perform actions against the AWS API using those IAM roles. Do go entirely keyless if that's possible and have that fully automated approach to deploying instances in a way which gives you the benefits that we just described on that last slide. And do look to strike a balance between static armies and dynamic bootstrapping so that you get the right sort of profile as far as startup time is concerned. Something you should definitely not do, and we unfortunately do still see examples of people doing this, which is do not put API access keys into code. There's no need to do it. You can manage your API access keys using IAM roles. And if you do that, definitely do not publish that code. We still find examples of people that have put access and secret keys into Git repos and made them public, or put them in armies which they've then shared via the marketplace. So please avoid doing that. We don't want people to be using your AWS accounts in a way which is unauthorized and potentially running cost up for you that you don't want or need. So it's a good way to lock down your account and really keep your hands on what you should really consider a payment instrument. You know, your AWS credentials are a way that you spend money, so it's a good idea to have them locked down and treat them with some care and restrict access to those people that really need them. So let's move on now from automation, and we're going to cover a few other topics. Block storage, we're going to talk about load balancing, auto-scaling, and CloudWatch in these last 4 sections. So block storage, first of all. We're going to help you here just understand the difference between instance storage and EBS. So instance storage is local on-host disk volumes, the data on those volumes is dependent upon your instance lifecycle. Now you can contrast that with EBS, which is network attached, optimized block storage, which has data lifecycle which is independent of the lifecycle of your instance. So we'll just explain that in a little bit more detail. So the instance storage, these local on-host volumes, you can see here examples of a couple of hosts that are running instances. And within those hosts, there are instance stores, which are local on-host disk volumes. You can see them here notated as F0 through to F3 on each one of those two hosts. And they are dependent upon instance lifecycle. And what I mean by that is if an instance reboots, either unintentionally or intentionally, and reboots on the same physical host, data in the instance store will be persisted. However, if that underlying drive fails, or you stop an EBS-backed instance, or you terminate an instance, data on that instance storage will be lost at that point. And you're probably asking yourself, if that's the case, why would I use these instance stores? What are they good for? And the answer to that can really be found on this next slide, which describes the instance storage that is available with the different types of instances that AWS offers within the EC2 service. And you can see that I've highlighted just a few of those as examples of instances that have high-performance SSD instance stores. So if you have applications that need very, very high sustained levels of I/O, very, very high volumes of random reads and writes, for example, but your applications are capable of managing data protection within themselves, then using that instance storage can be a great way to optimize performance and also reduce the costs of running those applications. And I'm thinking here particularly about one type of application, which is a super common use case for this instance storage, which is the NoSQL data source, NoSQL data stores, scale-out NoSQL data stores like MongoDB, for example. If you're running those on Amazon EC2, then you can use these instance stores. They manage sharding and data protection across a fleet of instances that will be running that software. And by combining that with these high-performance SSD-based instance storage capacity chunks, you can really accelerate the performance of that kind of application and reduce your cost by doing so. So a useful resource that you can definitely make use of if your application works in the right way. Just comparing that with EBS, so this is how EBS looks. So you're going to have a hypervisor, which is running obviously with your instances sitting inside that hypervisor. And when you boot an instance from an army, we create an EBS snapshot from the reference copy of the army, which is held in S3. And we then attach that snapshot to your instance using the network, and you boot your instance from that snapshot. So what you have there is off-instance storage, which can be persisted independently of your EC2 resources. But in wanting to persist it, you just have to be aware of a couple of default behaviors. The first default behavior is that EBS volumes that are attached to an instance while it's running will automatically detach from the instance with data intact when that instance is terminated. So you can keep those, reconnect them to another instance, or just retain them on the off chance that you might need them in the future. The other default option is that if you create EBS volumes at the time that you launch an instance, so you create and attach them at the time of launch, the automatic default behavior is for those to be deleted when you terminate that instance. But you can modify that by changing a flag within the console or specifying a flag within the CLI or within an SDK that you're using. And that will prevent EBS volumes from being deleted on termination. And you can then, of course, reconnect those volumes to another instance in order to replace a failed instance with the same data set, or to simply retain the data that's on those volumes for later use. So that's a good tip to use for data protection. Bear in mind, of course, though, that you will pay for data volumes that are retained in EBS for as long as that data persists. So let's move on now and talk about elastic load balancing. So ELB is a mechanism for spreading the load and fronting EC2 and distributing connections across those large fleets of instances that we described earlier. This is a regional service, so it will load balance across availability zones within a region. And in fact, you should make sure when you're using this that you have a balanced amount of compute capacity across the different availability zones that your load balancer is configured to distribute traffic across. That's important for performance reasons. So what you can do with the ELB is you can spread your load. You can go small on your instance types to reduce costs, but you can go wide to improve availability, and you can balance your resources across AZs. So if an AZ fails, your application will self-heal and additional instances will be started in those availability zones that remain. You can offload some processing onto an ELB, specifically SSL processing, and you can also use pretty complicated and sophisticated health checks with an ELB. So an ELB health check does not necessarily have to be at the front page of your website or the main page of your application. You can develop specific pages, screens that you might present back to your ELB with specific checks in them that will verify availability of different layers of your application. So by doing that, you can have very sophisticated and good visibility of the availability of different components of your application, distributing traffic across instances that are healthy or retiring instances that have failed on the basis of quite sophisticated checks which you can customize and develop yourself based on how your application works. So it's definitely worth exploring this idea of custom health checks and how you use those. Some tips for getting the most out of ELBs. Firstly, persistent HTTP connections, enable them, and that will optimize connection performance between the ELB and your servers and reduce the number of TCP sessions that are being created and torn down. So that will optimize performance from ELB to server. Never ever address the underlying IPs that you resolve for your ELB. Always use the DNS name. That's because DNS resolution is part of the algorithm and the method that's used to distribute traffic from an ELB to the host behind it. And different clients around the world may be provided with different resolution addresses for the DNS name for your ELB to help distribute your traffic. If you use underlying IPs, you will prevent that, and you'll end up with unequal distributions of traffic, and potentially you could cause issues if part of your ELB infrastructure fails. It will be transparent from a DNS perspective, but it may not be transparent if you use the IPs. If you span your ELB across availability zones, always have an instance in every availability zone. And it's also a good idea to deregister instances from an ELB before you terminate them. So you can do that via the console or the command line. And it's commonly used in continuous deployment techniques to replace all of the instances behind an ELB with new ones. So create your new deployment for your new application version, get that happy and get traffic delivered to it, and then deregister the instances that have your old application on them. That will smoothly transition your customers or users across onto your new application version in a transparent way. And lastly, you can use something called Trusted Advisor to identify whether or not you're following best practices for the use of your elastic load balancers. This is something that's available to customers that take advantage of business level support or above with AWS. Now, business level support is available from $100 a month, and like all AWS services, it's commitment free. So you can simply take business level support for a month at a cost of from $100. Use that to identify whether or not you have load balancers and actually many other things within your AWS account configured in an optimal way. And if you feel that you're not getting value out of Trusted Advisor beyond that month, you can of course cease it, or you can keep it at that pretty low cost point. So a good idea to help you understand whether you, for example, have your EC2 availability zones balanced adequately and you have the right amount of compute resources in each AZ to get the best out of your load balancers, and also assure that you'll have good availability in the event that there's any problems with an availability zone. So use the Trusted Advisor or experiment with it at least. Auto-scaling. So we've talked quite a bit about large farms of compute resources, and we've talked a little bit about load balancers. How can you automate EC2 commissioning and decommissioning? The answer to that is to use auto-scaling groups. So there's 3 bits of information that you need to create one. The first is a launch config. The second is an auto-scaling group, which you configure. And then lastly, you need a policy to drive the number of EC2 instances within your group up and down. And we'll look at each of those in sequence. So launch configuration, you can see, is pretty much the usual suspects. So you give the launch configuration specification. You're basically providing the same information that you provide when you launch an instance. So you're defining here what kind of instance is going to be launched by your auto-scaling group, and you also have to name your launch configuration. You then create an auto-scaling group which back-references the launch configuration that you've defined, and also names the group, defines which availability zones it's going to be active in, any load balancer that you want to register the group with, and also the minimum maximum size. And you can see that here. So you're defining the launch configuration that you're going to use. You're defining the load balancer that you're going to integrate this auto-scaling group with. And then after that, you need to create a policy. So this is a auto-scaling policy that will scale a group up. And this is an auto-scaling policy. Sorry, this is an auto-scaling policy that will scale a group down. You can see we're using damper here at the bottom. So the damper is a mechanism for preventing too many auto-scaling actions being triggered one after another, and you having what you could, I guess you could consider sort of jitter within your auto-scaling group, where you're constantly scaling up and down. It's not a good idea to do that, because whenever you start an instance, you'll be billed for a minimum of 1 hour's use on that instance. So by using that damper, you can prevent there from being too many scaling actions. And this is the scale down policy that we talked about earlier on, which will of course remove an instance from an auto-scaling group. Now we've showed you the command line there. Quite recently we introduced a wizard-based approach to creating auto-scaling groups as well. So if you go into the EC2 console, it's now possible to create an auto-scaling group and to be guided through the process in an interactive way. And you can see where that is on the EC2 console menu here at the bottom left, highlighted in orange. You create an auto-scaling group here, and it will take you through those three activities: creating the launch configuration, creating the auto-scaling group, and then setting up some thresholds to trigger scaling actions. So it's extremely simple to use. It's good practice, actually, even if you've only got one instance, to configure an auto-scaling group with a min max of 1 for that one instance. And then if your instance fails for any reason, auto-scaling will take care of the restart on your behalf, and you won't have to. So that's a good little tip to use also. So how do you know what's going on so that you can trigger those scaling actions? This uses an associated service which is called CloudWatch. And CloudWatch basically allows you to use metrics that are gathered by AWS services. And here we're looking at some EC2 metrics that are available to us. And you can see metrics are presented in a variety of different ways. So looking at the EC2 metrics there, you can see metrics per instance. You can see metrics aggregated by auto-scaling group, by image ID, by instance type, or you can aggregate across all instances. And once you have that aggregate, you can use that aggregate to create a trigger that will drive your auto-scaling. Here we're looking at an aggregate of CPU utilization across all instances within EC2. Not much data there, unfortunately, because I created this screenshot yesterday, but that data track at the bottom left of that slide would normally be populated with historic data for your instances in aggregate. So how much CPU is consumed by your aggregate group of instances, and obviously that's what you would use to drive your scaling actions. So for example, setting CloudWatch alarms so that if CPU is above 50% for 5 minutes, we're going to drive the scale-up policy. And if CPU is below 30% for 10 minutes, we're going to remove some capacity and activate the scale down policy. And that's how you would use CloudWatch alarms. So let's just have a quick look at the interface for that on the scale up side of things. And here you can see within the wizard-based approach to creating an auto-scaling group, you're asked whether you want to keep the group at its initial size, which would be that auto-healing scenario that I just described a second ago, or whether you want to scale the auto-scaling group in response to metrics. And we've selected that second option here. And we would create an alarm, clicking the Add New Alarm button that you can see in the background window there. And that would then take you into this Create Alarm dialog, and this is where you would determine whether you wanted to use an average, a min or a max, what metric you wanted to use, whether you wanted to use less than or greater than or equal to, what percentage threshold you wanted to set, how many time periods and how long the time period should be that you're going to measure over. So a powerful way for setting metrics which will trigger auto-scaling actions for you. You can also see at the top there, in this particular case, I'm sending a notification to an SNS topic, which is an email SNS topic called CloudWatch Alarms, which is going to be sent off to my Amazon account. And you can actually have, obviously because that's using SNS, you can deliver those auto-scaling notification actions to any kind of SNS topic, whether that's posting a message to a queue, posting it to a HTTP endpoint, submitting it into an API, in other words, or as I've just demonstrated there in that example, sending an email. So you can trigger these actions and also be aware of what actions have been triggered in real time, or retain those actions over a period of time so that you can track how your auto-scaling is working, when your policies are being triggered, and potentially optimize that with things like time-based or schedule scaling in order to anticipate demand rather than react to it. So very powerful tool in combination with the auto-scaling to use CloudWatch metrics to drive those scaling actions. And these are some of the other potential benefits that you can get from CloudWatch. So we've talked there about auto-scaling. There's a lot of other stuff you can do with it. One of the things that you can do, which is pretty cool, is you can create your own metrics via SDKs. So you may have noticed, for example, there wasn't a metric there for memory utilization, because memory utilization is a host-side metric. But it's quite common and pretty easy to post memory utilization from your instances into CloudWatch and use that to trigger auto-scaling rather than CPU. But you'll need a custom metric for that. And there's plenty of material available on the AWS website that explains how to create custom metrics, and memory metrics are some of the examples that are used there. So I'd encourage you to explore that if you're interested in learning more. Okay, so that concludes the core part of our webinar for today. Just to recap, we've talked about terminology, we've talked about how you can think of an instance in order to help you manage your instances in the right way. We've talked about instance types and security, talked in some detail about tools and bootstrapping instances and how you can automate that to improve scalability and recoverability of your environment. We've talked about block storage, EBS, and instance stores. And lastly, we've covered ELB, auto-scaling, and CloudWatch. So we've covered a lot of material today, but despite that, there's still more stuff that we could have gone into. So and you might want to explore these in your own time. So resource tagging, you can tag resources in EC2, and you can use that to manage and aggregate your billing. Route 53 is a DNS service that you can use to front EC2 and ELBs and integrate your DNS with your compute resources and load balancing resources in a very responsive manner. Techniques that you can use for rolling deployments. We talked a little bit about that in the context of ELBs, but you can also use Route 53 to manage rolling deployments, and you can use those same tools for application A/B testing as well, which is a pretty cool use case. And we didn't also cover Beanstalk, OpsWorks, and CloudFormation, and these are sophisticated tools for further developing the idea of automating deployment of EC2 resources. So one of them, Beanstalk, is about providing a stack with containers for running popular code developed in popular programming languages. OpsWorks allows you to manage stacks within your EC2 environment as layers and use chef recipes to automate EC2 configuration. And CloudWatch allows you to template a massive variety of different AWS services, including EC2, but also CloudWatch alarms, SNS topics, load balancing, and EBS resources. So CloudWatch is a very powerful tool for managing a broad portfolio of different AWS service components that might underpin your application or service. So to summarize, you can stop doing these things with EC2. You can take away the requirement for you to provision and fix servers. It can help you stop treating your compute as physical things and start to treat compute as a logical and disposable resource. And you can also stop thinking of compute as a finite commitment. You can use EC2 as you need it by the hour, and when you don't need it, just stop it, and you won't be paying for it anymore. And of course, there's some things that you can start doing as a result of that as well. So you can improve the security of your environment. You can improve elasticity by using stateless auto-scaling applications in the way that we've described today. You can automate the creation of instances and automate the destruction of instances when you don't need them. You can tag resources for better cost awareness and also optimize which instance types you're using for better cost efficiency. You can unconstrain your environment by having really the opportunity to get rid of capacity planning and just use the resources that you need when you need them and don't use them when you don't. And lastly, you can move to this model where you build your resources from scratch as you need them, and that's when you need them the first time and also when you need them to replace something that's not working. So really start thinking about this idea of disposable and easily replaceable compute as a way to transform the way in which you run your applications, workloads, and services using AWS EC2. As usual, you can find a whole lot more information about EC2 and other AWS services if you visit us at aws.amazon.com. There's a huge amount of documentation and resources there. The EC2 product detail page in itself, if you printed it out, would I think be several hundred pages long, so there's a ton of information there about how you can use EC2 and what the potential benefits and use cases are. And I encourage everybody on the webinar to download the materials, and if you only visit one link within the materials, make it that one and take a look at how you can use the services. For another opportunity to learn more about AWS generally, we have these summits that are upcoming in locations around the world. The first one is actually taking place in San Francisco in a few hours, so that's later today. If you're on the West Coast, you've probably still got time to register and get along to it, maybe. I'm not sure what the registration status is. You've definitely got time to register and get along to the other summits, and these summits will take the form of boot camps together with an educational program which will help you learn more about a wide variety of AWS services. On EC2, there's some great content, both starter level content and content that's to do with optimizing cost on EC2, and also content that's to do with optimizing scalability on EC2, as well as a focus session in London for sure, which looks at advanced scalability use cases for EBS, for running high I/O applications on EC2 in combination with EBS. So there's a lot of relevant content at the summit, and I'd really like you to come along if you're able to one of our events. And you can register by following the links that are available when you download the materials, or visiting us at the short link that you can see on the left-hand side there. And just one other set of resources. So we're active on various social media channels, but the main channels that we use are Twitter. So follow us at AWS_UKI if you want to stay up to date with what we're doing with webinars and events here in the UK or in the English language elsewhere in Europe. Follow us at AWS Cloud if you want to know more about AWS service announcements and feature announcements. And there's some pretty big ones coming over the next couple of days with that summit, which is taking place today in San Francisco. There'll be quite a few announcements, I think, as a result of that. So follow us on AWS Cloud if you want to stay up to date with that. And of course, if you've got feedback about the webinar today, you can rate us. And of course, you can follow me on Twitter, and you can send me any feedback that you might have on Twitter or any questions that you might have. And I'll do my best to try and answer those for you. So that's the content. We've got a massive number of questions, as I suspected, and there's unfortunately no way that we're going to have time to go through all these in today's session. So let's just pick a few from the top of the list that were submitted during the session. We will follow up on the rest of them, okay? So there's a question here about any advice for best practices for shared storage on EC2, and what I can do with that is refer you to a video of a session that was delivered at our user conference, reInvent, in November last year, which is a video which talks about techniques for running NFS and CIFS services on EC2 and making that available as a resource to other instances that you might have within your VPC. So if you were to Google, for example, AWS NFS CIFS reInvent 2013, I'm pretty sure you would find the answer to that question in the form of a fantastic video which is delivered by one of our essays, which goes really deep into that topic. So take a look at that, and you'll get a very good answer about how you can implement shared storage services on EC2 using a variety of commercial and open source tools. Okay, another question, do we have time to provide some more detail on Route 53 A/B testing? We'll do that very quickly. So with Route 53, you can have weighted resolution sets where you would have a DNS record which would be resolved differently by a specified proportion of the clients that want to resolve it. And by using that, you can distribute traffic onto a couple of different ELBs, which might present different versions of your application, or even into a couple of different regions, different AWS regions around the world. And obviously, you could do that for performance reasons as well as for A/B testing reasons, but that's how you would do that, using Route 53 weighted resolution to direct a certain proportion of your clients to a certain infrastructure set. So that's an answer to that question, how to use Route 53 for A/B testing. See what else we've got here. The slides are very fuzzy and hard to read. I'm sorry about that. You can download the materials. There are some restrictions on the webinar platform. The materials that you download will be in high res. So do grab the materials, and you can see the slides in high res, as well as access all of the links that are embedded within the slides as well. Okay, a question here about, can you let your application generate an auto-scaling trigger? Yes, you can do that. You can generate an auto-scaling trigger directly from your application by posting a CloudWatch alarm directly from your application using the SDKs that I described earlier. So a mechanism similar to that memory example that I gave. You can have custom metrics within applications, and those custom metrics can indeed be used to drive auto-scaling. Okay, so I can say we answered about 10% of the total number of questions that we've got there. So I'm very sorry that we didn't get to everybody. There's a huge number of questions that were submitted. We'll get our SA team to follow up on them, and you'll be hearing from the relevant SA that's assigned to your account over the next few days with either a request for more detail or an answer to your question if we can answer it easily. Please rate the webinar, and of course, please visit us via our social media channels. Follow us on social media, and you can stay up to date with what we're going to be doing next. So I'll just thank you for joining us. Thanks for your time and attention. Really appreciate it as always. And I'll see you in a couple of weeks for the next European English Language webinar. Bye-bye.